What is up, good people? This is section 2.1, solving equations and inequalities. Let's dive right in. If we're going to solve this equation, we can combine our like terms, and we get 2 plus 1x is equal to 3x minus 15. Adding 15 to both sides, we get 17 plus 1x is equal to 3x. Subtracting 1x from both sides, we get 17 is equal to 2x, and dividing both sides by 2, we get 17 over 2 is equal to x. Don't fear the fraction. Here we go. I think you can do this problem. Pause it right now and tell me what you get. This equation is a little strange because when you subtract x from both sides, you get negative 7 is equal to 0, which is not even a true equation. Turns out, if you think about the original equation, it's kind of like asking what number minus 7 is equal to your original number. And there are no numbers in which this case is true. As reflected by here, you don't even get a true statement. So, there are no real solutions. Or you could just write, there are no solutions, period. No solutions. There's a symbol for that in mathematics, looks like that. But you can do either way. It's kind of like saying, well, you asked me a question that has no answer, which is not the same as x equals 0. That's not even what we're saying. X equals 0 would be an answer. We're saying there's no answers. Check this out. What number plus 6 is equal to 6 plus that original number? Well, it turns out if you subtract y from both sides, you get 6 is equal to 6, which is absolutely always a true statement. Turns out you can say that all numbers are solutions. It's saying that every possible number you could think of is going to be an answer, a correct answer to the equation. A symbol for that, if it were all real numbers, a symbol for that would be here, all real numbers. So you can write either if you want. Here we go. Example 11, we remember quadratics from last chapter. Wait a second, 25, that's a square number, and so is 1, and so is x squared. In fact, if I let a equal 25x and b equal 1, then I get, let's see, now this is going to be a squared and this is going to be b squared. I wonder if the 2ab term will be 10x. Let's see, 2 times 5x times 1. Yep, that is going to be 10x. So this is 2ab equals 0. This whole equation is a squared plus 2ab plus b squared equals 0. So I can say that this is a plus b squared equals 0. What squared is equal to 0? Well, that original thing, a plus b, has got to equal 0. What is a and b again? That would be 5x and 1. So 5x plus 1 is equal to 0. When I solve that equation, I get x is equal to negative 1 over 5. That is the one solution. Let's try this one. I think I can factor this by grouping. And remember, the grouping method requires us to take the GCF of the first two and this GCF of the second two terms. GCF of the first two is going to be x squared, and you get 5x plus 1. And I know there's subtraction here, so what I'm going to do is I'm going to just factor out a negative 1. equal to 0. And look, we've got two 5x plus 1s. So when I factor that out, 5x plus 1, I get x squared minus 1 is equal to 0. I can further factor that, can't I? 5x plus 1 is equal to x plus 1, and x minus 1 is equal to 0. Now that it is completely factored, I can write them as individual equations. And in fact, this is the whole point why we teach you to factor. This right here is actually the reason. The one big reason why we factor is because you can take this step right now. 5x plus 1 is equal to 0, or x plus 1 could also equal 0, or x minus 1 is equal to 0. The whole reason why you can factor is that you can turn each of those factors into individual equations and solve them. So here we get x could equal negative 1/5, or x could equal negative 1, or x could equal positive 1. So, just a reminder, I want you to not forget, please, when solving equations, don't stop at the factored equation. Don't stop right here. Make sure you split up the equation and solve. It's really using the zero product property. Principle. Alright, so example 15 in your book says solve and graph 17 minus 5y is less than or equal to 8y minus 5. We can do this. It's the same exact process. I'm going to add 5y because I don't like subtraction. Get rid of it by adding. We get 17 is less than or equal to 13y minus 5. Add 5 to both sides. We get 22 is less than or equal to 13y. And so therefore 22 over 13 is going to be less than or equal to y. So if I were going to graph this, maybe I'll switch around the inequality just so it's easier to graph. (22 divided by 13 is 1.69. I find that it's always easier to graph. So we have 0 here, we have 1 here, we have negative 1 here, and here is point 1.69. Here's 2. There it is. Determine the meaningful replacements in the expression square root of 22 minus 4x. Well, we want to make sure we don't have a negative square root. So that means we have to make sure that this whole thing is going to be greater than or equal to 0. It can equal 0, fine. It can be greater than, fine, but it just can't be negative. So when we solve this, we get 22 is greater than or equal to 4x. Then dividing both sides by 4, you get 11 over 2 has got to be greater than or equal to x. If you wanted to write it in set notation, you need to make sure that you can, x is less than or equal to 11 over 2. And by the way, did I mention to you that London is the capital of England? That's just your audio check right there, so you can write that down. Again, London is the capital of England. One more thing that I wanted to make sure you knew is that you need to begin assignment 2A. I want you to write the heading and do the first problem in your composition book. That's great, and I'll see you in class.